Okay, so to follow up what we did in class, we are going to talk about three specific things for homework. So we're going to talk about square roots of monomial expressions, and we'll talk more later about what monomial means, but it just means there's one term and it might have variables like x, y, and so on. We're also going to talk about cube roots. So cube roots of integers. So we're going to see some cube roots of negative numbers. We'll talk about those. And then lastly, we're going to talk about multiplying radicals. So we're going to see what happens when we actually multiply terms with radicals. All right, so let's just talk about square roots to begin with. Just a little review what we did in class. So if you take the square root of 24, I like to break this down into the prime factorization of it, so break it down into the most basic factors we can. So when I think 24, first thing I think is 8 and 3. 3 can't be broken into anything else, so I like to underline it. 8 can definitely be broken down into 2 times 4. 4 can't go anywhere else, or 2 can't break down to anything else. 4 can be broken down to 2 times 2. All right, everything is broken down as far as it can be. It's a square root, so we're looking for groups of 2, looking for pairs. So we have a pair of 2's here. Then we're left with 2 and 3. There's no more pairs. So now on the outside of our radical, we have a 2 from here. And we're left with this 2 and this 3. So on the inside, we have 2 times 3. We can simplify that. 2 root 6. 6 cannot be broken down into any perfect squares, so that's our result for number 1. Okay. All right, let's do number 2. So number 2, we're going to practice a cube root. So let's take the cube root of 40. Now you might break yours down differently than I do. You'll see that no matter what factors you use, we're always going to end up with the same solution at the end. So when I see 40, I see 4 and 10. 4 can be broken down to 2 times 2. 10 can be broken down to 2 times 5. Now, since this is a cube root, we're looking for groups of 3. Well, I see 2, 2, and 2. That's a group of 3. And I don't have a group of 3 of any more numbers. So that group of 2 is going to go to the outside of the radical, 2. Cube root, make sure you include that cube root. And all that was left was that 5. So our final answer is 2 cube root 5. All right, for the next one, this is where we're going to see a monomial expression. So we're going to take the square root of 200x cubed. So this is something a little bit different because we see a variable, but it's the same exact process that we've been doing. So let's start with what we know. We know how to break down 200. We have 2 times 100. 2 can't be broken down. 100 can be broken down into 10 times 10. Now, if you want to break 10 down further into 5 times 2 and 5 times 2, you're welcome to do that. But if I see that I have 2 numbers that are exactly the same right there, I don't even need to break those down further because I know that I'm going to have a group of 2 10s, and that's going to come to the outside of my radical sign. So if I started out, I got 10. I know that's going to be on the outside. We've broken down 200 as much as we can. 2 is the only one left over on the inside, so we have 2. Now let's break down this x cubed. Well, x cubed just means x times x times x. It's 3 x's. Since it's a square root, we're looking for groups of 2. We have a group of 2 x's, so that goes on the outside of our radical. And we have this one remaining x that stays on the inside of the radical symbol. 2 cannot be broken down any further. X cannot be broken down any further. So that's our final answer right there. 10x square root of 2x. Let's do another problem like that. So this is problem number 4. So we're going to take the square root of a monomial expression. So we're going to have a coefficient, 120, x to the 4th, and then y. Okay, let's start with the number 120. You could break that down a couple different ways. I see 12 and 10. When I see 12, I see that's 4 times 3. 10 is 2 times 5. 2 and 5 cannot be broken down any further. 3 cannot be broken down. But 4 we can make 2 times 2. This is a square root, so we're looking for groups of 2. You see any groups of 2 of anything? Yeah, absolutely. We got 2 2s, only 1 3, 1 2, 1 5. So we know a 2 at least is going to go on the outside of the radical sign. Okay, so I'm going to leave some space after the 2 though, because we might be putting some other stuff there. All right, so we simplified 120. We broke that down. Let's look at the x's. Well, x to the 4th just means x times x times x times x. There's 4 x's. We're looking for pairs. Well, here's a pair of x's, and here's a pair of x's. So we're going to have 1, 2 x's on the outside of our radical symbol. Lastly, if we break down y, well, y doesn't have any factors other than y and 1. So y cannot be broken down any further. So that's going to remain on the inside of our radical. So let's see what we have. I'm going to scoot this down a little bit. We've got 3 times 2 times 5. 3 times 2 times 5. And then we have a remaining y. This doesn't look very nice. We need to simplify this. This becomes 2x squared. 3 times 2 is 6 times 5 is 30. Y. So our final answer is 2x squared square root 30y. All right, so we talked about square roots of monomial expressions. We'll get to cube roots in a minute. Let's talk about multiplying radicals. So our next example we're going to say is number 5. And let's say I give you 3 root 2 times 2 root 6. This is actually a lot simpler than it may seem. But what we're going to do is we're going to start with the terms outside of the radical, 3 times 2, and we're just going to multiply them. Well, 3 times 2 gives us 6. Okay. Then on the inside, we're going to take the numbers underneath the radical symbols and we're going to multiply them. 2 times 6. But notice they're still under this radical sign. Okay? So we got 6 from 3 times 2, and we got 2 times 6 underneath the radicals. But this can definitely be simplified. 6 is good to go. We can simplify 2 times 6. That's just 12. Now, this might look like we're done, but we have to ask ourselves, can we break down 12 into any roots? Can we take the square root of any factors of 12? And yes, we absolutely can. 12 is broken down to 4 times 3. 3 is done, can't break that down. 4 can be 2 times 2. We're looking for a square root, so we're looking for groups of 2. There we go. Group of 2 right there. So our final answer, give you a bit more space. We're going to bring this 2 to the outside, so we have 6 times 2, square root, and a 3 is left over. Still not done though. That is not in simplest form. Got to multiply 6 times 2, get 12 root 3. Final answer. Let's do one more example where we're multiplying square roots. So multiplying radicals. So we have, let's say, negative 5 root 3 times 2 root 12. It's the same process we did last time. Let's start with the numbers outside of the radicals. So negative 5 times 2 gives us negative 10. All right, next we're going to start with what's inside the radicals. 3 times 12. 3 times 12. And remember, those still have to remain under the radical sign because they started under the radical symbol. Okay. All right, negative 10 is good to go. 3 times 12. Well, what is 3 times 12? It's 36. We can definitely simplify this. Can we take the root of 36? Square root of that? Absolutely. We're left with negative 10 times square root of that is just 6. Negative 10 times 6, negative 60 is our final answer. Okay, for the last part, we're going to talk about the square roots of negative numbers. So let's say you have an example like this, the square root of negative 25. If you try to put that in your calculator, you're going to get a big error. Error! That's a problem. If you have a square root of a negative number like that, you can't take that. That doesn't exist. It's a negative number. However, let's say you saw an example like this. I think we've seen this before. Negative on the outside, negative square root of 25. Well, square root of 25 is 5, so the negative square root of 25 is just negative 5. So be careful. If you have something on the inside like that, it's going to give you an error, but if it's on the outside, it will apply. Now there's a difference here when we talk about cube roots. So let's say we have, for example, 9. The cube root of negative 64. Now this is actually a time when our calculator won't give us an error, because let's think. Can you break negative 64 into 3 factors that are the same? So what's a number that you can multiply by itself 3 times that will give you a negative 64? Well, positive 64, positive square root of 64 would be 4. So let's just check. Let's try negative 4, because we're talking about negatives. Negative 4 times negative 4 is 16 times negative 4, and that gives us negative 64. So actually, if you have something like this, a cube root of a negative, you can get a negative answer. So the answer to this is negative 4. We'll try another example. Try number 10. This will be our last problem for today. So we're going to take the cube root of negative 125. Well, let's see if we can break that down into 3 factors that are all the same. And yes, we can. Negative 125 can be broken down to negative 5 times negative 5 times negative 5. I'm looking for a group of 3. I got 3 negative 5s. That's our answer. If you want more practice on this, you can go to IXL. Your login is your lunch number or your student ID at VB Schools. And your password is the first 2 letters of your last name. So if I was doing this, it'd be SH, and then your lunch number. Okay? It's not vbschools.com. There's no .com. It's just at VB Schools. And if you do want to get more practice on this, you can go to Algebra A6 and Algebra A7. Make sure you're in algebra. Okay? Okay, have a great night.